Hello, fellow ETM 1120 students for spring 2020. My name is Dawson Saunders, and the mini project I chose to do was the product teardown and documentation. I only did one item because it was rather large, and I chose the Schwinn S500 electric scooter. So this is the actual product before teardown. Like I said, it's the Schwinn S500 electric scooter. One thing I noticed right off the rip is just the build quality of this thing is very high for something like an electric scooter. Compared to its competitors like Razor, where a lot of the parts are plastic, they're really I think there's only two plastic parts on this thing, and it's the deck and the rear kick panel. The rest is either steel or aluminum. But with that, the obvious drawback is weight. The scooter weighs almost 60 pounds, but obviously it's a lot more stronger and it can hold up to 240 pounds. So going into the actual teardown now, I started by listing the electrical components. So as you can see on the left is the 500-watt battery that powers this scooter. And then in the center is the controller, the wiring harness, and the controller case. The top right is the throttle, and the bottom right is the on and off switch and the charger port. So the battery's main job is just to power the motor. The controller translates inputs from the throttle to the motor. The controller case is pretty simple. It just protects the controller from dirt and water. The wiring harness is very crucial. It transports all inputs and power throughout the entire scooter. Throttle, it just controls the speed based on user input. And the on and off switch activates and deactivates the battery, which is pretty self-explanatory. And the charger port, when connected to the charger itself, it recharges the battery. Shown here is the drivetrain assembly, which is similar to the transmission, the axles, and say a regular car. So on the left, you can see the chain guard, the motor guard, the motor, the chain, and on the right is the sprocket. The motor uses power from the battery to move the chain. The motor guard protects the motor from collision damage. The sprocket gets spun by the chain, which is welded to the wheel and turns it. The chain spins the sprocket, and the chain guard protects the chain from any sort of damage, and it also acts as sort of a guide. Pictured here is the brake assembly. The brake assembly is very spread out across the scooter. There's parts on the handlebars and parts on the back, so literally the entire scooter. But the brake lever is pictured on the left, which is on the handlebars. The brake cable and the pinch bolt are on the very rear of the scooter, and then the band brake housing is actually on the other side of the wheel of the drivetrain assembly. So the brake lever tightens the brake cable. The brake cable puts tension on the drum inside of the band brake housing, which this is actually the first time I've ever heard of a band brake housing. So basically the way it works is it's similar to a regular drum brake, except however there's a band that goes around the drum itself, and when the brake cable is pulled, it tightens the band around the drum, which stops the wheel. But going back to this, the pinch bolt allows the brake cable to tense up and tighten the band, and the band brake housing just contains the drum and the band. Next is the seat assembly. So as seen on the left is the seat tube. In the middle is the seat post clamp. And on the right, I couldn't get these two apart because they're welded together, but it's the seat and the seat post. So while these aren't very vital parts, it's pretty crucial to user comfort. So the seat tube connects the seat post to the frame. The seat post slides into the seat tube. The seat clamp allows the user to adjust the height of the seat by sliding the seat post in and out of the seat tube. And then the seat just provides the user a place to sit when riding. So these are all parts I couldn't really put into a category, so I just kind of pictured them all together. On the left is the frame and the handlebars. The bottom middle is the reflector. The top right is the wheel assembly, the kickstand, and the kick tail. And then the bottom right is the deck. So the frame on pretty much anything does the same thing, any sort of vehicle that is. Um, it's just a supporting structure, which is exactly what it is here. The handlebars allow the user to steer. The wheel assembly contacts the ground and allows movement. The kickstand allows the scooter to stand on its own. The kicktail protects and conceals the drivetrain assembly. The deck protects and conceals the battery. And the reflector is just a safety device for when riding at night and such. Last but not least is the hardware required to put this scooter together. There's only three really noticeable pieces of hardware, and that's the stem bolt, the stem dowel, and the stem clamp. The rest is just kind of basic nuts and bolts and washers. So for the three notable pieces on the last slide, the stem bolt allows adjustment of the wheel and the handlebar angle. The stem clamp allows the angle of the handlebar to be changed. So unlike the difference between the stem bolt and the stem clamp is the stem bolt locks which way the wheel is in regard to the handlebars. The stem clamp allows the handlebars to be moved front and back to help the user reach when they're sitting on the seat. And then the stem dowel is clamped by the stem clamp to lock the angle of the front and back movement of the handlebars. So now on to part 2 of the product teardown and documentation. During my teardown, I counted 30 parts. Now to discuss how everything is made. The battery, the case is made by casting, and the internals are lithium ion and zinc oxide. Those are inserted. The controller, similar to the battery, the case is made by casting, and the internals are circuitry, which is made by printing copper. The controller cover is simply just bent sheet metal, and then holes are machined out for the screws. The wiring harness, the wires are made by forging because they have to heat the metal and then stretch it into wires. The throttle contains wires, which are made by forging, but the twist mechanism itself is injected molded plastic. Just like the throttle, the on and off switch contains wires as well, but the switch itself is injection molded. And the charging port contains wires, but the port itself is bent sheet metal, and the cover and the adapter piece is injected molded plastic. For the motor, the case is made by casting, and the gears inside are powdered metallurgy, just because of how specialty they have to be. The motor guard is forged metal. The sprocket is machined metal. The chain is made by machine metal and attached by rivets, and the chain guard is just a casting. Onto the brake lever. It's made from machining metal. The brake cable is similar to the wires I mentioned earlier, where they're forged, where the cable needs to be heated and stretched out. The pinch bolt is just machined metal, which is almost all the hardware on this machine is just machined metal. And the band brake housing was just made from casting. So the seat tube is extruded aluminum. The seat post is extruded aluminum. The seat clamp is machined metal. And the seat itself is just simple upholstery work, so stuffing and sewing. So the frame is forged metal. The handlebars are forged metal. The wheels were machined metal. The kickstand, the plate that attaches is machined metal, but the rod itself is forged metal. The kicktail is thermoform plastic. The deck is thermoform plastic. Those two pieces are very similar. And the reflector is thermoform plastic with the reflective material on the inside. And then this page is about all the hardware, and it's really basically all made the same. So the stem bolt is machined metal, the stem dowel is machined metal, the stem clamp is machined metal, and all the other nuts, bolts, screws, washers on the scooter are all machine metal as well.